Hi everyone, welcome to MathSpellBook. I'm your host Peter, and basically we are going to get into real analysis today. So, basically I've been letting my curiosity just go about, and I have a set amount of problems assigned to me by my friend Sascha to do, so I thought I would do those. And I think it's the same, and it's funny because there's actually recommended problems here, and it's funny because he hasn't seen this page, but he did assign me problems from this book, and it's funny because all the exercises that he assigned were actually from this book. They're all on the list, so I thought I would do those with you guys today. I don't know how many we'll get through because there's around 6 problems he assigned, and I think here is 1, 2, 3, 4. It looks like there's 4 on this page, but all of them are actually assigned by him, so, and they're on his list, so I thought I would just basically do that with you guys today. Okay, so I think maybe a couple of them are not on this page, but we will get into that. So I think we should do something that I'm familiar with. This. I know I've done this one many times. Let's reduce this to 70 because I usually like the way the pen looks when it's at 70. Alright, so let's just get to this. How are you guys doing? It is Monday after all, so hopefully you guys are having a decent Monday so far. Whether you be studying or whether you be working or whether you're doing both. Probably at the register, well, the shift is not busy. Alright, so proof. Or maybe we should just write let. I think that would be easier. Let x be an element of the intersection of a and b complement, which implies not an element of A intersection B. This means that X is not an element of A and not an element of B. However, X is an element of a complement or X is an element of B complement. Thus, X is an element of A complement union B. Okay, so now we gotta do the right hand side. For the right hand side, suppose we should do it the same way we did before. So. Hey Archimedes, how are you doing? See, it's your first time chatting with us. What's the best part of your day so far, Archimedes? Loving the name though. Alright, so now I gotta remember how to write this last part. For the right hand side, well, I've been reading some geometry. Oh, what type of geometry? For the right hand side, suppose that X is an element of A, complement, union B complement. I feel like I want to break this down a little bit more though. But I don't want to do it in the typical way. Well, maybe this way. So, for X indicating not an element of A. And X is not an element of B. Therefore, X is not an element of A intersection B, which implies X is an element of A B complement. Planar Euclidean stuff, the basics. Oh, that's good. It doesn't like the basics are usually they're usually like good to go back to. I have to get back to basics myself sometimes, so which implies, see, suppose which implies that or along with X is not an element of A and not an element of B. Therefore, X is not an element of the A intersection B, which implies that X is an element of the intersection B. Okay, so that seems to, I feel like the logic flows there. Thus, that's the proof. Okay, I think we gotta do part B. But I think I'm getting the hang of those type of proofs there. If there's any errors in my proofs, please let me know, guys. Because the better I get at proof writing, the more we can do more exploration. So, like, are you a student, Archimedes? I'm guessing that's why you're, like, reading up stuff, or are you just doing math as a hobby, like me? if you are a student, are you like doing undergrad, graduate program? What path are you on your mathematical journey? Well, I'm a CS grad. Oh, okay, computer science graduate student. Nice. Is it master's or PhD? Okay, let X be an element of A which implies X is not an element of A union B. Knowing this, X is... No, I don't like the way this is phrased. This... Masters? Okay. Do you know what you're going to be researching for your master thesis? Right now I'm just deliberating what word choices I should write to make it a full sentence. Hence... X is not in A, or X is not in B. But X is an element of not A, and X is an element of not B. Meaning X is an element of Okay. So now for the right hand side, suppose X is an element of meaning X is not as it's not an element of A, and X is not an element of B. Well, actually, I should write the reverse, so it's like C. C. Not sure what exactly I'm going to choose, but I want the subject to what? on the intersect of math and okay, so maybe theoretical. Oh, okay. Yeah, like I guess like with physics, we're kind of like aware of the theoretical relation between math and physics within theory, but I never know like I guess the latest theoretical frameworks or questions within computer science. So, do you want to share those? Because I feel like if computer science has like I guess theoretical frameworks that it really wants to answer within the theory of computer science, it probably might help a lot of fields in STEM. Is an element of a complement. Check my proof to make sure it's right. So, implies that hence meaning for the right hand side, suppose that x in A union B, but X is in A union B complement. Okay, I think that reads pretty good. So I think that proof is done. Of course, I've done this proof like many times, and it took me a long time to actually understand the structure of what I need to do with it. So I'm kind of glad that I managed to actually start learning how that is actually structured for De Morgan proofs. So according to Sascha, we don't need to do all of them. We need to do A, B, and C, and D. So, and if you guys don't know, Sascha is like my friend slash teacher, or tutor, as it were. Because he's trying to teach me the ways of actually doing real analysis without having to over fixate on like certain thresholds. Not sure what exactly. Oh yeah, I already read that. I always wanted to learn more about the literature of complexity theory and computation theory. Oh, okay. I always draw Venn diagrams for those kind of proofs. No, that's fine. I mean, if you have a lot of visuals, it might help you actually. I think you can do visuals in proofs, but it depends on what type of proof you're doing. So I don't think there's anything wrong with that. The only thing is that I don't know if a professor would approve of that, to be honest with you. But then again, I wouldn't I think a professor will like probably write down on your exam. It's like, oh, okay, I love the visuals, so you know, it could be that, or like the professor's like, good use of visuals, but like I don't think it's necessary for the proof or something like that. All right, so what are we supposed to do here? For each of the following, find all the numbers x for which satisfies the expression. Oh. Okay. So the one thing is that are we just supposed to think of different numbers, or are we supposed to think of like an actual like setup, like a theoretical setup here? All right. So x minus 4 is equal to 7. All right. So it's basically the distance here for the absolute value. So I think we have to. The one thing I hate about this online version is that there's no table of contents, so I can't jump around too much. So here's the definition for an absolute value. Do this. And I think we might need to... I don't know why it always does this. So expand that. I think the rules of absolute value are also important. I'm just doing this because I know definitions are important here. Yeah, for mathematicians, proof by pictures is not rigorous, so I might use it as a way to understand the problem visually, as you said. Yeah, I think like visuals are always great, especially for people that are not into like doing the rigorous approach. For me, for me it's like rigorous, like I feel like it takes a lot of time, but I understand why mathematicians do it, so it's like they don't waste too much time. Like, I mean, they basically just get the details done. And I think that's probably good enough for them to have all the details laid out, so they don't have to worry about missing a beat with the explanation and the logic. But if you like math and physics, and you also need a study stream to keep yourself productive in front of your computer, you know, consider dropping a follow if you're watching this on Twitch. In addition, if you're watching this on YouTube Live, you know, hit the sub button. It always helps out the channel. In addition to, like, hit the like button and leave a comment down below. Okay, so... do we need the triangle inequality? I don't think we need it though, because it says each of the following, find all the numbers that x satisfies. Okay, so usually 11 minus 4 gives you 7. Gives you 7, and it's the absolute value, so that means it's gonna work in the reverse. So so we have -3 minus, so that would also help. So what we know is that we need -3, because then that will turn that to -4, and that will be -7, and thus giving us 7. Also 11 will give us that. And I don't think we're gonna use like things like I mean, yeah, I use it also in real analysis in the epsilon delta proofs the definition. Oh, okay, I see. Yeah, because like I think I haven't worked with like epsilon delta proofs like within calculus. Like we skipped that part because I think it was because it was a more rigorous chapter, and I think like in community college they don't teach you like the more abstract mathematical proof version of that. That was when I actually tried to go back to school once. Hey Hans, how's it going? I still haven't figured out your pattern yet. I still haven't figured it out yet. It's a real tricky one actually. So I don't know if they just want you to do a proof on this, or they just want you to pick the numbers. Well, it says final the numbers would satisfy the expression, so I guess we can write this as like maybe scratch work if we have to do a more proof version of it. So 4 minus, which is less than 7. I mean, I'm just writing in a set notation, so it's like less cumbersome. But I think this one is going to be more like so minus 4, so we go up to 11 here, so we go from -3. So this one could be an interval, like a closed interval, because it's going to be less than 7, so then we can have a closed interval like this, and I think like that, because if we have 11 here, then that basically it will stop at 7, but if we have 12, then it'll go to 8, which is higher than 7. And I think anything within this interval will always be less than 7 at that point. I could provide more numbers if needed, or give another type of hint. If you would like to, like in the same channel, yeah, like in the, if you guys ever want to put like mathematical patterns, like just for fun, for like everyone to look at in the Discord server, you can always put it in the assignments from stream channel. That way everyone can like engage with the fun project. But what's the best part of your day so far, Hans? Since you just came in. Okay, so okay, 2 plus, I mean x plus 2 less than 1. Getting an A+ on my guitar test. Nice, nice, that's good. I didn't know you know how to play the guitar. What type of songs do you like to play on it? It's 6 here in Norway. 1 to 6 are the grades. Oh, okay. I see. Just basic right now. Oh, okay, that's good. I remember in high school, one of my high school friends played guitar. This is just 9th grade. 9th grade. Oh, okay. I see. I mean, how are things in Norway, though, Hans? So it has to be less than 1. So if we have 1 here, then that means we can't have a half or anything, so it has to be from, we can't even have 0 in here, so meaning that we gotta have from -1 because if we have -1, then that will turn into just 1, and then we have 1 to the 1. Actually, it probably might be in a half open interval, because we can't have 0 in it, but we can have like negative, so probably we'll have not 0, but anything after 0. No, wait. Because if we have 2... plus 2. That's still 1.5, so we can't even have a negative half in there. So if we have 3/4 plus 2. So anything, so practically we can only have -1 in here. Because anything lower, so anything, because then if we have, yeah, if we have anything higher than -1, or like lower than -1, then it's basically going to increase, and then that's going to be higher than 1, so the only thing we can have there is -1. So it's like set of -1. Let's see. Cold, eating porridge right now. Very Norwegian thing to do. And many views have gotten boring because you see them all the time, and the milk I'm drinking right now tastes like peanuts. Don't know why. I don't know. Maybe you have to check. Maybe you have to check the milk. But that's hopefully it's not like spoiled milk or anything. So we have X. I think the milk company has gotten a bad batch. Oh, dang. Hopefully it doesn't cause you to have a bad eruption in your stomach. Usually, like, whenever I have cereal and I put milk in it, I always, like, if it tastes funny, I'm like, yeah, I don't want to eat the cereal anymore at that point. Okay, so X minus 1 plus X minus 2 is greater than... Okay, so this will go to 0. And if this is 0, so if we have 0 here, then it's 1, 0, that's 2 plus 1, that's 3, that's greater than 1, that fits. So if we have the negative numbers here, that would also work. So I feel like either way, this is gonna go to, like, we can have a range from like any number. So if we have like 1 minus 1, that's 0. 1 minus 2. Yeah, so then 1 minus 2, that would still be 1. So that's the only one that doesn't work. So I think we can have from negative infinity to 0. So as long as it doesn't touch 0, because like oh no, so it's like 1. So as long as it doesn't touch 1, that's what I meant to write. So 1 minus 1, that's 0. 1 minus 2, that's -1. Then basically like that changes into +1. So if you have -1 here, so then -2, and yeah, that still works. Math at school is boring. Math at home is fun. Math at school is hasty. Math is challenging. Yeah. I get what you mean. I get what you mean. So I think we're supposed to just find all the numbers. Because this one is just going to be a set of 2 numbers. This one is just going to be an open, it's going to be a closed interval. This one is just a set, just one number. Because then if we have -1 here, then that would be -1 and then... No, wait, hold on. Oh no, that doesn't work either. Luckily I checked that. Because if we have -1 here, then that would be -1. And then this, that's regular, so we can't have that one. Because even if I have a negative number, let's say we have -3, then that would be 1. So if we have -4, that would be 2, but then that's greater than 1 still. So I think this is just the empty set, because I don't think there's any number that we can put in there. Because if we have 0, then it's 2. And if we have, like, say, -1, then that would be just 1, and that's still not less than 1. So math is trivial. My interior. Hey, Magic. Major Finger. What's the best part of your day so far? My teacher doesn't provide enough material because I'm ahead of the class. Oh. 60% of the math class is waiting for the others to get it. I mean, at least you're, like, ahead of your class, so, you know, that allows you to, like, free your brain up for, like, more things that trigger your curiosity. Because, like, when it comes to school, it doesn't end, like, when it comes to your learning, it doesn't end when the school door closes. You know, like, when you're out of school and you really like to learn, like, fixate on the things you like to learn. So if, like, the math at school is not challenging you, then you could probably open up a math book to something that is probably more interesting to you. So in other words, like, if you don't know calculus, then, like, learn a little calculus. And then once calculus is not challenging for you, then you can move on to other levels of math. Maybe, like, do a little bit of multivariable calculus, and then once multivariable calculus is under your belt, then you can do, like, differential equations. You know, it's like all those little things. Yeah, so 1 would make that 0, 1 would make this 1, and therefore it's not graded. Okay, so I think those are the numbers we're dealt with. This one I'm surprised about because, let's see if we have 0 here. Even if we put a fraction, like a negative fraction in here, let's see if we do -1/2. Well, actually, let's do negative 2.5 plus 2. So that's -1/2. Okay, so I think I found one that might help us. So -2.5. Yeah, because that will bring us, like, -1/2, and then that will be 1/2, and that will be less than 1. So let's see if we do negative. Okay, so basically only this one works. So and -2 plus 2, that's 0. Okay, so I think we found our sweet spot. So it's probably going to be from that will be, yeah, so weird, because I remember every country pretty much having one on, but look into it. Yeah, I mean, like, if you want to really challenge yourself, like, I guess, like, the Math Olympics is, like, the Math Olympiad is probably going to be real fun to do. I've been waiting so much in class. At one point, I knew the first 50 digits of pi. Oh, nice. Yeah, I don't even remember, like, I think the first, let's see, 3.1415. Yeah, that's all I remember. I never really bothered to remember the rest. But that's pretty good, though. So... Now the one thing I have to make sure is that range perfect for what we have? So it's like 2 and 2.5. So let's see if we do 2.6. Okay, so that works. So let's go 2.9. Okay, so it doesn't end there. So I think it's gonna be from 2 to, I think, -3. Or maybe I should write it in the reverse because negatives are always going to be the reverse direction. So -3 to -2. Yeah, because it's always going to be less than 1 at that point. So yeah, there we go. 92653589. Oh, okay. I mean, at least you remember like the first 50 digits of pi. I can't even do that. For me, like, I think it's just hard enough to remember the speed of light, which is like, I think it's 292,458 meters per second. I think that's the speed of light. I could have gotten my digits mixed up. Okay, so I think, let's just check through here. So I think this is fine because we got like a whole lead up here. This one was probably, we had to check over and over again to make sure that we were on the right track. So I think this one is okay. So I think we got this up. So we got like a union here. I mean, these are just the numbers that I think would work here. Because it's the absolute values, so the absolute values are always going to change up. I never actually looked up how the speed of light is. Maybe that's next. Yeah, I mean, it's not that hard. If you memorize like 50 digits of pi, I'm pretty sure you can remember the actual exact speed of the speed of light, at least in textbooks. Because I'm pretty sure it's like 299,792,458 meters per second. Okay, so I think we're done with that one. 50 digits of pi I learned from a song, though. I mean, at least you remember it from a song, because, you know, like, people just want to learn the hard way by just memorizing. So I think it's better that you remember it from a song than just trying to remember it by full force. So I think the next exercise we got to do is 9.1.9. So it's this one. Is there anything on the exercise here? Okay, and I think we have to do exercise 1.10. Okay, let A and B and epsilon be elements of an ordered field. Okay, so I I just want to get the definition of an ordered field so that I don't have to look it up. Ordered field, here we go. I just don't want to remember all the axioms, so I'm just gonna find where here it is. Because I know there's a lot of axioms for being in an ordered field, but I know this note has like all of them related to the real numbers. And usually I think it's up to here. That's where it's an ordered field. Because it includes the 6th axiom. But I think with the 7th axiom, that's where you actually get the real numbers. Do you have any specific things you are struggling with? The pattern, by the way. Well, I'm here. You know, well, I have to get back. Well, I have to actually look at the pattern again. Because I know it has nothing to do with, like, making the sum of the numbers. But I think it's because I haven't spent too much time on it because I've been reading other math as well, so... Yeah, it's fine, because sometimes, like, if I really want to put the challenge to it, for me, I don't mind spending, like, an eternity on a problem. Sometimes it's just good for me to put it down and just, like, pick it up whenever I feel like the energy is going to be, like, fueling. In other words, like, if the flames aren't burning for that particular problem, then I just let it settle. Okay, so show that if A is less than B plus epsilon for every epsilon greater than 0. Oh, thank you for the follow, Cranberry Banana Salad. Nice name. Do they go well together? I'm pretty sure they do. Because now that I'm thinking about it, it's like cranberries and bananas. Now I'm thinking of like a yogurt for some reason. Maybe that's the only way they'll be a salad. You sure it has nothing to do with adding numbers up? Yeah, because like the thing of it is that I will be honest, I haven't been looking at your pattern that much because I've been like doing other stuff. So I probably just need time to sit down with it. Hey, cranberry salad. What's the best part of your day so far? And thank you for the follow, by the way. I'm guessing you like math or physics or both? Or you just needed a study stream just to keep yourself preoccupied. Either way, you're in good company. Do I need the definition for... I feel like I need a definition for something with supremums. I think this one. We need like the theorem here. Maybe, I don't know. Maybe not. But I feel like we just need it. So pull that up there. I want to get better at math and physics. Oh, okay, cool. Same here. That's why I'm doing these streams. I'm not going to school or anything. I'm just doing it as a hobby, but it's always fun to be able to engage with you guys that are just as passionate about the subjects as I am. So show that if A is less than B plus epsilon for every epsilon greater than 0, then A is less than or equal to B. Okay. So we'll put A, show that if B is less than B plus epsilon for every epsilon greater than 0, then A is less than or equal to B. Okay. Alright, Or maybe we have to do scratch work first. PFPs? What are PFPs? Oh, profile picture. Are you talking about on my Twitch? Like basically the banner and stuff? For the banner, I made it myself. Before I had another banner, but like I decided to change it. I actually took like the picture of the eyeball for the banner. I took that from like a video I made like years ago. And I was like, maybe I should turn this into my banner. And then like I just decided to turn it into a banner and add a few equations in it. And then along with a little bit of a cool mathematical diagram I saw. And I was like, oh, why don't I just put this there? And then like it just worked. And I was like, okay, this feels like the vibe of the channel I want. So. But for the icon, like my friend designed that, the little circle with like the book and the book opening up with like I think like magical aura around it. Like my friend drew that for me. That one the icon you see in the Discord, that's basically my friend designed that one for me. Okay. All right. So. Now I'm thinking like how we should start. So, because I'm wondering if we should start from the end and then work our way in here, or we should, let's see, using part A, show that if Now I'm wondering if we write this proof, it will end up answering part B too without realizing it. Oh no, it's not. Okay, because it says A is equal to B. Okay, so I think they're both separate parts, but I think we have to use part A for B in this case. To show that if... Oh, I think we need the epsilon definition, I think. Because it looks like it's... it looks like it's requiring us to involve that. The Archimedean principle. Let's see. I want to make sure that we get the right stuff here. What is the question? I haven't been paying much attention. Don't worry, I'll get back to it. I'm just trying to find a definition that might help us in this situation. We got a distance here. I don't know when they actually start introducing epsilon. I think they start doing epsilon like after this part. Yeah, I think they did it after this part. Yeah, I think like epsilon is introduced like later than this. Yes, this is analysis. This is real analysis. I'm just trying my best to understand it, at least. My friend Sasha gave me like 6 problems from this book. Because I asked him like on Friday how to actually, what problem should I focus on? And he looked through the questions and he was like, oh, do this problem and do this problem. So, you know. Analysis is fun when you actually read the definitions and you get to understand it deeper. I think like with the problems it gets a little bit tough because then I have to think about how to set up the proof and everything like that. Yeah, so I think epsilon is introduced in this section, so yeah, because we have to think about bounds, like the least upper bound and the greatest lower bound, all these different things. Let me reread this part. So assume that I and I1 and I2 for the supremum that we wish to show that alpha is the upper bound. For any other upper bound beta, we have that alpha is less than or equal to beta. We all have only the latter to prove. Assume that beta and the others. Okay. So epsilon is less than now since epsilon is greater than 0 by this might actually what we might need to do. So let's see, show that if a is less than b plus epsilon, for every epsilon greater than 0, then a is less than or equal to b. So should we first start out writing that let epsilon be maybe we can try that. So it's an ordered field. So let a, b, and epsilon be elements of n. Whoa, I didn't like the way I wrote that a there. Of n ordered field. What is epsilon? Epsilon is this little thing here. That's epsilon. So if you're asking about like why we're using it, it's just that it involves this theorem here, supremum analytically, this theorem. So it basically says let A be a subset of R, then the supremum of A is equal to alpha. Alpha is an upper bound of A, and given any epsilon, and in this case any number that is greater than 0, alpha minus epsilon is not an upper bound of A. That is, there is some x in A, which is x is greater than A minus epsilon. I mean, that's for the supremum case, but for the infinite case, it's the opposite. It's basically like beta plus epsilon is x is less than beta plus epsilon. So if you were to ask me, epsilon is basically just like kind of like the measuring gauge. It's like you're turning a dial and you're just trying to see which side is which. So that's basically what epsilon is a nutshell, at least for like our purposes here. So let A and B and epsilon be elements of an ordered field, which is why I have this here, because I want to make sure that I remember everything that we have in an ordered field. Show that if A is okay, so now I have to think about how to set this up, because I feel like the proof that we saw here kind of helped me a little bit to think about it. Because what is the proof we need to do? So for alpha, given any epsilon greater than 0, and I think for this one we have to show now, since epsilon is less than, we know that is not the upper bound. epsilon minus a alpha minus epsilon. It's not an upper bound. Okay. Let's see, since epsilon is greater than 0, okay. Now, I don't think it's going to be as simple as they had it there, because like since we have to make a less than b plus epsilon, I think we're going to have to figure out how to make this work. So do we have to change a into something else? Or do we have to change b into like say like a, oh no, I mean change epsilon to like say like a minus b or something like that, but I don't think we can do that. I mean, because I'm wondering if we should start over here, like this part, or do we have to find a way to like make this part get into this part here? That's the one thing. Because we can write this in the proof easily. It's like suppose that a is less than or equal to b. So maybe we could try that. Suppose a is less than or equal to b. Now, show that if a is less than. Let's see, for every epsilon greater than 0. Let's see how they do it in this direction here. The forward direction of the proof also works well by contrapositive. The contrapositive of a, so for all epsilon greater than 0, there exists some epsilon supreme is not a. Okay, let's see what this is. Supreme of a is 0. Okay. So I mean, are we supposed to do this to lead to a contradiction? Because for some reason I'm thinking that if we did do it, like basically say that suppose that epsilon is equal to like a minus b, then like basically we would get like a is less than a, which is a contradiction. But I don't know if that's the exact way we should approach this proof. Because like use part A to show that if the absolute value of a minus b is less than epsilon, for all epsilon greater than 0, then a is equal to b. I mean, that one, it feels like it's a little bit self-explanatory. I mean, It's not obvious, but it feels as if like we can like change epsilon to like, you know, a different number. Okay, so maybe I should write down the... Let's see, just like small scratch work here. Okay, so what is our purpose? Our purpose is to show... We have to show this through this relationship. To bring in supremum or I don't think we do we? Or do we have to? Maybe we might have to. I don't know. There's nothing about supremum or infimum in here. But epsilon only shows up when it involves like supremum and infimum. So I guess we might have to involve them. So it seems like... I have to say, suppose A is an maybe we should label the ordered field. An ordered field. So we have an ordered field F now. So do we have to assume that A is in lower bound? Because it seems like we can show that. Sometimes when it comes to these moments, like I probably should like, I'm going to try to ask ChatGPT to give me a partial hint. Let's see, here's a short targeted hint, no full write-up. Let's see, try proving contrapositive, assume that that means that A is greater than B, then the difference okay, I mean that felt like more than a hint, but sure, let's try that. Assume A is greater than B, and epsilon is equal to A minus B. Okay, so let A and B be elements on an ordered field F. Assume that A is greater than B and epsilon is equal to, okay, so if we do that, then A is less than epsilon, and then this implies that which axioms did you use when you added? Contradiction, perfect. The next step is to phrase this cleanly. State that because assuming A leads to a contradiction, the only remaining possibility by exactly one, and when you write it up, explicitly mention where you're using the next step is carefully phrase the contradiction you assume from the assumption you constructed another particular epsilon. Really? I should probably write this. Epsilon is possibilities left for the relationship between A and B in an orb field. Like now I'm just trying to see like how the logic is built here because I think it's like I'm trying to think of like because we're doing it by proof by I think it's kind of proof by contradiction in a way because we're assuming that the opposite of this, or I guess like the complement of these two, and what we got was a contradiction, so basically it's like equaling it to itself, so basically it can't equal less than itself, so we can only conclude that A must be either less than or equal to B. So I guess this is proof by contradiction. And I'm wondering if that is the way to answer the proof. Because I think it is, it's just that I want to make sure that we're done here. Maybe I can ask far. I sometimes like ask ChatGPT to look at it. Okay. At least it let me kind of ask that, because when I think about it, it kind of feels like I already did show the contradiction here. Because it makes me feel like that this is actually completed. So, okay. So I guess that is it for that one. So I guess this is proof by contradiction. Okay. So okay, so now we're on to B now. Use part A to show that if A and B, A minus B is less than epsilon for all epsilon 0, then A must equal B. So for this part, using part A to show that if... Okay, so I guess we're gonna have to write this proof again, so... Proof. Let A, B, and epsilon be elements field. Assume A is less than or equal to B. Epsilon is greater than 0, and epsilon is equal to don't have to write this part. Somebody into DC got it. Oh, okay, cool. Well, at least someone solved it. How does it feel to have it solved? Epsilon. So then we will have B minus epsilon and A. Okay. I don't know, weird, good and bad. Nice, it wasn't impossible and not too easy either. It took some time before people got it, which I think is good. When it comes to math puzzles, yeah. Like, I'm glad someone solved it, because I'm like, but I'm not gonna try. I'm gonna try not to look at the solution that they typed up, because that's how stubborn I can be with stuff like that. Because I mean, it took, like, for this proof, I had to basically let my brain fester on it for a while, but then I'm like, okay, I'm taking too long thinking about it. So then I had to go into ChatGPT to ask for a hint. And I think it's better for you to ask hints rather than just pull out solutions, because when you get hints, your brain is slowly creeping into the solution without knowing it, and then you just basically let it kind of crawl there. And then, like, when you get massively stuck, that's when you actually have to, like, type in a little bit, like, you know, inching your way towards, like, the solution. Just basically let yourself not go to all the way to step like 100. Just basically crawl, like, probably like step 5, and then you're like, can you give me step 10? And then, like, basically you get to step 10, and then you're like, okay, I can work my way up to getting to step 20 to 50, and then, like, once you get to 50, you might hit another stumbling block. It's like, can you give me to step 60? You know, that sort of thing. Epsilon is less than A, and A greater than epsilon plus B, or less than epsilon B. So for this one, alright, so I'm just going to type for a partial hint for B, see if we're on the track. If you give a partial hint for proof in part B. Cases, okay. split the case, split it into cases using the definition. In either case, compare this with the result in part A. What does part A tell you if it's less than epsilon and then epsilon is greater than 0? It should help you narrow down the possibility. Okay, so I guess they didn't want us to use this part. I thought we were gonna find something clever with that, but I didn't know where. Alright, so epsilon is greater than 0 and epsilon is equal to A minus B. If the epsilon is less than epsilon or greater than epsilon? Less than epsilon. Then we have two cases. One where another where right? Is that how they wrote it? Oh, it's equal. Okay. Where A is greater than B, right? It's greater than B. Then okay. So I guess we're gonna have to test out these scenarios. Case 1. Case number 1. A is greater than B, and A so it would be guessing that's the reason why we split these up here. If A is greater than B, then delta is equal to A minus B, which is greater than 0. Now check the condition. Some of this. Alright, Hans, thanks for stopping by. Best to you, man. Take care of yourself. Thanks for stopping by. progress with this. that's enough. That probably might not be exactly what I'm looking for, but we'll go with it. But yeah, I mean, like, I did have to go into ChatGPT and just basically like type up stuff to basically like get hints on how to do it, but I think that's the only way for me to actually learn. It's just basically like, because I didn't think that I need to do it by case. But that probably shows like how much I don't remember, like I don't think about the definitions as much. I'm actually liking it because, thanks for the question, Archimedes. Yeah, I'm actually liking it because it feels as if it's like a real analysis book that's meant to talk to me as someone who doesn't fully understand real analysis. So I think I like the book, and plus, I love how in the appendix, Jay Cummings basically talks about how to construct the real numbers, like through like I guess a more rigorous way. Like he even mentioned that this was the most boring approach, but like that was the same technique that Sasha taught me. So I was like, oh, okay. So maybe like I can, but like he does leave some details out, but I think I really like that. So okay, so I think we did how many problems? We did 1, 2, 3. So we did like 3 of them. Of course, I don't know for this one, we had to do it through a proof method, or do we had to do it for, we just had to find the numbers. So I think we were supposed to just find the numbers, because it says find all the numbers which satisfies the expression, so I think we did pretty well with that one. This one, we just basically had to go with ChatGPT to find like exactly what we were looking for, but at least we were able to like piece it little by little, so I think this proof will stick with me just to basically get a better understanding. So I think for next time, like maybe, I think like tomorrow, we're going to be working on 1.10, which is this one. And then we're going to do 1.14, which is this one. And then we're going to do 1.20. And Sasha said, like, for, I guess, like, if we want to get extra practice or, like, try a little, I guess, a fun activity, we can do 1.22. So there's still more to come, guys. So practically we did like 3 problems. So I think that's pretty good. So hopefully we can get either the last 4 done, or get like maybe like 2 or 3 done, and then I'll probably like continue on forward with that. So it's about that time, guys. Thanks for joining me today. If you like math and physics, and you need a study stream to keep yourself productive while you're in front of your computer, or maybe doing your homework in between classes, if you're like in college, you know, consider hitting the follow button if you're watching this on Twitch. If you're watching this on YouTube live, just basically hit the subscribe button, in addition to leave a comment and leave a like on the video. It really does help with the algorithm if you want these streams to keep coming up on your feed, and hopefully that will keep you productive on your mathematical journey, or your physics journey, or both, or just your academic journey in general if you're just studying something totally different. But yeah, that will do it for today, guys, and always remember, everyone is precious, You guys are just as precious as everyone else, and I will see you guys tomorrow for the next study stream. So take care, guys. Bye-bye.